Alright, we're going to be going over trig functions. Trig functions, we're going to be going over sine, we're going to be going over cosine, and we're going to be going over tangent and what it means. What is sine, cosine, and tangent? They're trig functions that revolve around the opposite side. Or we're just going to use O because I can't spell opposite. Deal with it. It revolves around the adjacent side, and it revolves around the hypotenuse, OAH. And these are all different parts of a right triangle. So let's learn how to identify these parts of a right triangle by drawing a right triangle. These functions only work on right triangles. If it's not a right triangle, you can't really use sine, cosine, and tangent. So we signify it's a right triangle by drawing that little square in the bottom. Now that we know it's a right triangle, we can do this. So automatically, first thing you should do is label. So they're going to give you a reference angle. We'll call this angle theta. It doesn't matter. This is only an example to learn how to name a triangle. So the first thing you should know, you should always label your hypotenuse first. How do you figure out your hypotenuse? It's going to be opposite from the right angle. So from the right angle, we can just draw a line outwards. It's going to touch this side. Since it touches this side, this is going to be our hypotenuse. Then from our reference angle theta, we can draw a line out. Same thing as our hypotenuse, it touches this line, this has to be opposite from it. Since it's opposite from our reference angle, it has to be the opposite side, obviously. Which leaves us with adjacent. Adjacent means it's touching a side. Well, and this is touching two sides actually, it's touching this one and this one. Does that mean that both sides are adjacent? Absolutely not. Adjacent and hypotenuse are two different things. Just because it's touching the hypotenuse doesn't mean the hypotenuse is the adjacent. The only way you could figure out the hypotenuse is if it's across or opposite from the right angle, alright? That's the only way. Even if it's touching the hypotenuse side, that does not make it the adjacent side. So now that we know this side is the hypotenuse, it can never be our adjacent side. We can like imagine that it's not touching this side, and it's touching this side, which makes this our adjacent side. So we have HOA, and we successfully labeled a right triangle. Good for you. Let's try this one more time in a different orientation. Let's just say, for this example, our reference angle was this one. So this is our reference angle. Obviously, the side hypotenuse is going to stay the same because it's opposite from it's opposite from the right angle. So that's going to be H. Opposite side here, we draw a line from it, it's going to touch this side, that's going to be O, that's going to be our opposite side. And applying that rule that the hypotenuse cannot be adjacent, this is the only side it's touching, which means this is the adjacent side. Cool, you should now know how to label triangles. This is 1% of trigonometry, congratulations. Now we're going to learn about now we can actually go on to sine, cosine, and tangent. And it's kind of hard to remember it, so there's a cool little saying called SOH CAH TOA, and basically it's a nice little thing to remember what sine, cosine, and tangent means. So let's figure out what sine, cosine, and tangent means. Basically, sine of angle theta, which is our imaginary angle, is going to equal to opposite over hypotenuse. The S stands for sine, the O for the opposite, and over hypotenuse, so SOH. The C stands for cosine. Cosine of theta is equal to adjacent, which is A, over hypotenuse. A over H, you can draw an imaginary fraction thing there. T stands for tan. Tan of theta is going to equal to opposite over adjacent. And that's basically it. That's what all of the functions mean. It's a nice little way to remember things. So now that we know what it means, let's actually try a trig problem. We're going to slowly but painfully and tediously erase this and erase all our labels to make sure I'm wasting as much of your time as possible, because MS Paint makes me suffer and you should too. Alright, so here is our right triangle. We identified it's a right triangle, which is step number 1. We identified the right triangle. Step number 2, we're given this angle is 37 degrees, let's just say that. Since it's the only angle given, this is now our angle theta. This is this symbol. We're going to plug it in whenever we do our thing. Now the second step, obviously, it's to label your angles. The side opposite the right angle is going to be hypotenuse. If we draw a line from 37, it's going to touch this, which is O, and it's touching this side, which is A. Cool, we labeled our triangle. Now, let's just say this side is 7, and this is x. Alright, so we're given our hypotenuse, which is h, and we're trying to find our opposite side, which is O. Which one of these functions has h and O? Sine has h and O, so we're going to have to use sine for this one. So let's set up our problem. We're going to do sine. We're going to write sine of theta, which in this case is 37. So sine of 37 is going to equal opposite, which is x, over our hypotenuse, which is 7. Now, at this point, you'd go to your calculator. You'd make sure you're on degree mode, not radian. Actually, no. You have to make sure that you are. I actually don't know if it's radian or degree. It's one of the two. Just search it up. I think it's. Yeah, I think it's degree. We'll find out sooner or later. So you type in your calculator sine of 37, and you'll get this really long number. Copy it down. Sine of 37 on my calculator is 0.60181502232. So we have this mess is equal to x over 7. We remember our basic algebra skills, which I hope we do remember. And in order to get rid of the 7, we'll just multiply by 7 over 1 on this side, and multiply by 7 over 1 on this side, which is the same thing as multiplying by 7 on both sides. This giant number times 7 is going to equal 4.21. That's our answer. That's what x is equal to, 4.21. Cool, you've successfully solved a trig problem. Are you proud of yourself? I hope you're proud of yourself. Let's try another one. So in this case, we're going to be using a different function, because doing the same sine function is dumb. Let's just say in this scenario, our reference angle is still 37, but I want to, and opposite side is still going to be x. But they give me the adjacent side as 8. Now I have to find this side. Once again, we label our we do the same thing as we did last time. We label everything. This is going to be hypotenuse, this is the opposite side, this is the adjacent side. Cool. This time we're still looking for the opposite side, which is O, but we're given the adjacent side, which is A. Which one of these functions has O and A? It's tan. So we'll write down tangent of theta, which in this case is 37. So tan 37 is going to equal to the opposite side over the adjacent side, which is going to be 0. Oh, nope. That's the... Oh, wow. You really... Oh, my God. Which is x over 8. Because adjacent side is 8, opposite side is x. Once again, we'll go into our calculator. Make sure you are in degree mode. If you don't know how to change that, search it online. I have a TI 84 Plus CE. Big flex. My calculator has color. Great spend of... Really not regretting my life choices spending $121 on a calculator, but you literally go on to mode, and then you scroll down to radian and press enter on degree. I don't know how to explain it without showing you guys, but it's not my problem. Anyways, tangent aside, I hope you skip through that. Tan of 30, you type in tan of 37. That gives you a big number. I'm too lazy to type it out, so let's just say it's 0.7535, alright, is equal to x over 8. We'll just multiply by 8 over 1 on both sides, multiply by 8 over 1 on both sides. This big number times 8 is going to be equal to 6.02, which is our answer. And that's basically how you solve trigonometry problems. Yeah, that's basically it. I hope I confused you even more than when you started. Goodbye. Boop.